Okay, in addition to using these tools to grab standard geometric information, standard geometric features, we also have the ability to scan freeform shapes. So for that I use the curve tool, and I'm going to just bring a curve shape into play here and use the curve tool to grab some data. Now, as an example, if I start the scan here and go in this direction and then set an endpoint, you can see that the system follows the shape of the part and delivers points around that curve. In many cases, you want to simply scan an entire shape. So and that's what I'll do in this case. I'll set it off in this direction and tell the software to keep scanning until it returns back to the start position, and you can see that interacts with the CNC control, drives itself around the part, and has in this case returned a point cloud of a couple of 100 points to describe that small shape. The point intensity is definable by me, and we can set up a much more intense point density. So here's the shape. If I zoom in on that on my part view, you can see that I've got a point cloud. But what am I going to do with this information? Well, the way that we use scanned information is to compare it to the CAD data of that file, using the CAD data as an electronic overlay, if you will. So I'm going to bring that into play now. If I go up to my DXF import form, I'm going to import a DXF as a curve profile, and I'm going to set a tolerance on the nominal profile of, in this case, let's say 10 microns. I'm going to browse to a location, and here are my list of DXF files that I have available right now. And if I go to this file here, I'm going to bring in a DXF. So let's zoom in. And over here, you can see this is where the DXF has come into my inspection. Let's just zoom in on that. And you can see it's a way off the actual current position of the part. So I'm going to need to introduce a new function here called grid shift. Grid shift allows me to make translations and rotations. And what I'm going to need is to bring this data somewhere close to where the DXF is, so that I can start to understand how far off the nominal line we are. So I just drag that using my right mouse button, and if I zoom in, you can see that I dragged it pretty close, but we've got a way to go. And as some of this data crosses into the border, the boundary defined by the tolerance band, data points which are in tolerance are shown in green, and those data points that are out of tolerance are shown in red. So what I can do now is ask the software to make that best fit, that final best fit for me. If I ask it to do that, there it's done. It's best fit iteration, and you can see that mostly this data point cloud is within that 10 micron tolerance band that I set. So it very easily allows the operator to see on a complex shape which areas of the profile are out of tolerance and it may need attention. Let's zoom in on a little area here, and you can see I've set a very, very tight tolerance on this, and right on that corner I've got one point that's out of tolerance. The advantage of this is that we can consider an entire shape in one shot and have one dimension associated with it. If I double click on that and select profile, you can see that I have a profile error overall on this part of 13 microns. So if my tolerance is set to 15, for example, I can see in one dimension that the entire shape of that of that part is within tolerance, rather than trying to break it into its individual geometric elements. So scanning and best fitting is a very powerful method of inspection. It's part of the standard package of software, and not only that, it can be totally integrated with other standard geometric measurements, giving you a combination, a kind of best of both worlds approach.